Okay, so this is not modern SQL if it's not apparently clear already. Modern SQL could probably be summed up in NoSQL nowadays. So this is a last-minute talk that they asked me to step in for. It's a gentle introduction to reactive extensions. It's gentle. Why? Because that's nice to put in the title. It's an introduction, meaning it really is an introduction. It's very, very basic level. If you've done any kind of RX, then please leave now. Anyone done RX at all? Okay, a little bit. So don't blame me if it's like, oh, this was too introduction. I don't take feedback that's negative well. I really don't like it. So if it's good feedback, send it to me. Okay? I always tell my children, I said, keep the negative things out in your life, right? So anyway, so we're going to start, and I'll start with a little bit about what and what not, which I've already told you. We're going to kind of see a little bit different aspects of reactive extensions. I'm going to be using a library called RX Java. But the same concepts apply in many other languages. RX is no longer a specific thing to .NET, which, believe it or not, .NET did have some good things. It still does, and RX was one of the things that originated there. Why? I always like to kind of like answer this question of why. Why do I do something? Why should we do something? And the reason for why do we need reactive extensions is because there is a reactive manifesto. Okay, so just like there was an Agile manifesto and now we all have to do Agile, there's a reactive manifesto. So we all now have to do reactive. But mind you, I'm a little bit sarcastic also, so don't take that seriously. I do find it very funny, though, that in our industry, anytime something comes out, the first thing that comes out after it is a manifesto. And then after that, there's a framework. So, yes, we won't be doing it because of the manifesto. Now, by all means, go and read this manifesto. It's signed by a bunch of people, and it talks about different aspects of RX. It talks about how it should be responsive, in the sense that when we create applications, they should be responsive. Absolutely. I just upgraded Android to Lollipop on my phone, and Skype now has become my personal pocket heater. It just heats my pocket. It doesn't do anything else apart from heating my pocket. So we like to have responsive applications. Resilient, because we don't want things to fail. Elastic, because Silicon Valley, right? We've been bombarded with this message that anything we do has to scale, right? How many of you do scalable things with like hundreds of millions of users daily? Right, okay, so, right. But you know what? You still need cloud and elastic computing for it. Because they said so. So I'm not too worried about that scale aspect, the whole elastic thing. Message-driven, there's this aspect of the manifesto that says that message-driven is better in the terms of like the bus, because we accomplish better decoupling and things like that. So yes, that does have some positive aspects to it as well. My reason is this, right? If you're old enough to remember this, which I tend to find less and less people my age, it's really scary. So how many of you remember this? Yes, exactly. This is how responsive applications shouldn't be, which is you drag, and it was fun that you could like, you know, do these little like things, drawings when your windows would hang. And asynchronous programming is basically hard. We all accept that. And we require it because, you know, whether we're doing a desktop application or whether we're doing a mobile application or a web application or a server-side application, it needs to be responsive in a sense, and there needs to be interactions with the user so that they know what they're doing. And the interaction doesn't consist in it's still, there's websites nowadays that you go to and it's like, you've clicked to pay. If you click again, you will be charged twice. Right? That's the easy way of saying, screw you, we're done. You know, we're not going to worry about your interactivity with us. We're just warning you, we will charge you twice. But, you know, we do try and make applications that are responsive and interactive. We've attempted to do this. Threading, how many of you do threading? Right? It's fun, right? And when you get to real low-level threading like fibers, and that's even much more fun. Async await. There's been attempts to do asynchronous programming with async await. Any C# developers here? Right. How's that worked out for you in C#? Great, right? You've had your entire code base plastered with async await calls. Yes? It's like they said, this is really fantastic. We've introduced 2 new keywords. If you want to do asynchronous programming, you take a procedure and you annotate it with async. And then you call await when you call that method. Yes. And you propagate that through the entire code base. Right? So it kind of looks okay, but it's not that okay. In Java, you have futures. I tend not to look at the future too much. Callbacks, I have done that a lot. JavaScript, any JavaScript developers here? Fortunately, we still have to do JavaScript in our lives. So there's this concept of callback, or otherwise known as a tilted Christmas tree, which if you look at your code sideways, it kind of looks like a Christmas tree, because it's callback inside callback inside callback inside callback, and known as callback hell. So that's not a very pretty thing either. And then JavaScript has introduced other things, such as like promises. It's even tried to introduce async await. So there's been various attempts to kind of try and solve this problem of synchronous programming. Now the issues that all of these have, obviously they've all got their great sides, they've all got their bad sides, you know, like everything, except JavaScript, that's only just bad. But if you like, one of the issues is that if you start to combine asynchronous operations, it starts to not be that easy. It starts to fall down a little bit and starts to become painful. In the callback scenario, you see it yourself. The callback hell, those embedded callbacks are because of I want the result of something, and then I want to take that result and pass it into something else, and so on and so forth. And the other issue is that, you know, it's different techniques for different languages. And I think that most of us live in an era now that we are more or less polyglot. Yes? How many of you do more than one language here? And it's great. We need to be polyglot. Okay? We can't just all do Java, even though we like Java, even though Java might be a great language, which it is. But it's always good to do other languages and have other perspectives on how people do things and solve problems in other languages. And also it opens up us more to the job market. So we do want to, though, at the same time, leverage as much as we can when we move platforms. And that's some of the things that Reactive Extensions has tried to address. This aspect of combining asynchronous operations, making it more readable, and trying to apply the same techniques across multiple languages. And that's what this Reactive Extensions comes in. So Reactive X is, as you can see here, it's very clear definition of exactly what it is, which is it says an API for synchronous programming with observable streams. And if you see there, here you can see it says choose your platform, which we'll get to, but here's the highlight of it, observable streams. Okay, so everything is a stream, right? And it's observable, right? So that's clear, right? Everyone understands that? Okay. You get that though, no? Okay, never mind. Right. Point being that probably what I just said absolutely makes no sense, which is great. That's fine. We'll hopefully at the end of the session it will make some sense. So let's take a step back for a moment and let's think about a couple of things. What is programming? Come on, somebody, please. You can answer me in French if you want. It's an art. And we are craftspeople, right? We're all craftsmen and women, yes? Agree? No. No, it's not. They just pretend to tell you that to sell manifestos. All we do is actually process data. I mean, that's what we do. We just take data and we process it. It's kind of like how you make whiskey. That picture's mine. That's a distillery. I love whiskey. Big whiskey fan. I have to say that all the time. That's Bruichladdich. And basically what you do is you take water, take barley, and out comes something beautiful, right? And it's kind of like what we do in programming, right? We take data, we apply some functions to it, and out comes something that hangs. But we try. And the important thing is to try, right? So all we do actually is data processing. So before, this was what data processing looked like, right? We were in these offices. So there's no craftsmanship here. There's no, okay, I'm joking. But before it looked like this. Now, of course, it's open office plan, right? It's the new way of saying we're really cheap, right? We don't want to pay for the cubicles. It's called open. We're more open, we're more agile. So the whole open floor offices are fantastic. It also sells a lot of headphones, especially Bose. So at the end of the day, though, what we're doing is just data processing. So we take data, we apply some functions to it, and out comes information. And this data can come in various forms. So you can have like scalars, so you have date of birth, you have sales, you have amounts, you have names, you have collections of data, so you have lists of countries, collections of customers, etc. And all we're doing is just processing this. So let's switch over and let me show you some code on how we process data, which I'm sure you all know. Now, there's a couple of things I want to, some like heads up and some warnings here. A few things before I dive into code. First of all, this talk normally is better suited as part of another talk that I have, which is the one that's coming after this talk, which is refactoring to functional. So a lot of these concepts and constructs that I explain here, you might not completely be familiar with. If you're not, it's okay, you can come to my other talk. Ideally, they should have done this the other way around, but they didn't because this was a last-minute thing. So it's fine. If you don't understand anything here, just give me a green vote and then come to the next talk. The second thing is that I'm using a language which is called Kotlin. How many of you have heard of Kotlin? Right. It's a language that we're working on JetBrains. It's open source. I'm using it. Yes, obviously, you can call me biased, but I really do love the language. And it's much more concise. Having come from C#, I like it very much. And it's kind of like a little bit like JavaScript, except you remove the madness because it's statically typed. I'm saying that dynamic typing is madness, but it's close. It's 100% interoperable with Java. Okay, so to all practical effects, you can mix Kotlin and Java. And in fact, I'm using RxJava from Kotlin. But having said that, you can use, I mean, the code that I'm showing you, and especially with RxJava, you can use it basically with any platform on any language. Okay? But, you know, the language is just a means to a transport mechanism. So here is a very simple example. I have numbers, a list of numbers, and what I'm doing is I'm looping through those numbers, and I'm just printing out the number. Everybody understands that. It's very simple, right? I have some syntactic sugar for that, which is for each, and all that does is print out the list of numbers. And then I also have a for each that is exactly the same thing, except just I've added a line break, okay? Just to show you the block. In Kotlin, you have the convention that if the last function, the last parameter to a function is another function, in other words, a higher order function, you can drop the brackets. So it reads much more like a DSL. Okay? So what I'm doing is I'm just looping through a list of data and I'm just printing them out. You can do a little bit more like sophisticated things when you have structures of data, and this will go into a little bit more detail in my next talk, but you have like more sophisticated things like I have a list of albums, and inside that album there's a bunch of tracks. Then I want to kind of like flatten that list out, so I can use constructs like flat map. Everyone know what flat map does? So what map does, map takes a function, it takes a collection, it applies a function to it and gives you another collection. Flat map takes a collection of collections and it does the same thing and it flattens it out into a single collection. Okay? We'll see this in more detail later. I'll stop saying that, I promise. And then what I'm doing here is now I'm just processing the results of that. And of course you can start to combine things. So now I can have, for instance, a list of numbers, and then I can say, okay, on those numbers, filter all of those that are divisible by 2, and then give me the last number that is divisible by 2. How many of you know what this gives? It should give you 10, right? Great thing here is that I'm taking a collection of items, I'm applying a function to it, that's giving me back another collection of items onto which I'm also applying a function, so on and so forth. So we're basically applying a technique called pipelining, just applying function after function. Okay? So that's kind of like the 101 of the minimum you need right now for aspects of like functional programming. But if you look at what we've just done, we've basically taken the interface iterable. In Kotlin, it was called a trait, now it's going to be called an interface, so very familiar with Java because right now it basically offers, Java 8 offers the same functionality that Kotlin now does with traits, well similar, in that you can have default methods in Kotlin traits. You could have default implementations. So that's why we named it trait. Now it's going to be renamed back to interface. But anyway, so what I'm doing here is I've got the iterable, which iterates over a list of numbers, and I've got an iterator, which gives me the next, and it gives me the has next. Okay, very simple. But if you look at this, what I'm doing here is I'm actually like getting a list, and then I'm iterating through this, and on each of these calls, I'm blocking. I'm blocking the call, right? Which is problematic. Because here, of course, it doesn't really matter because it's instant. However, if I do something like this, it's going to block the call. Now it's going to go off and get the growth figures, and then it's going to display those growth figures. So in that call, there's already a block. So the UI is going to freeze, right? Or your web interface is going to freeze, or your mobile application is going to freeze because there is a blocking call. And that's where we try and introduce asynchronicity, right? Now, the whole concept, everything that I want to show you in RxJava and Rx, Reactive Extensions, is basically just making this same code asynchronous. So you program it the same way as you would, just pipelining functions after functions, but the difference is it becomes suddenly magically asynchronous. That's the idea behind this entire talk, okay? Also, that agriculture in Spain isn't growing. So we shouldn't block. But if we think about what we're doing, we're actually waiting for data. So why are we waiting for data? Why not just get notified, right? Instead of waiting for data to come, why don't we just have this thing that we've very well known, which is called an event? When some data arrives, it just raises an event and says, I'm here, data has arrived, on data event. So I can do that. And that is part of something that you probably already know, which is called the observer pattern, right? The observer pattern says, I'm going to observe something, and when something comes in, let me know about it. So what I can do is take this concept of iterable and iterator, and we can try and like convert that into, instead of pulling data, pushing data, right? So that suddenly becomes this thing called an observable and an observer. So from an iterable and an iterator, we get observable and observer. And instead of getting next, I subscribe. That's it. It's as simple as that. And what that is actually a concept in mathematics called duality, which for anything that you ever want to know that is ultimate truth, you go to Wikipedia. And it says, you know, in mathematics, duality is theorem or mathematical structures into other concepts, theorems or structures in one-to-one fashion, often but not always, by means of an involution operation. What is involution? A function where you take a function with the parameter and it returns the parameter itself. Okay, so when you apply the same function to the parameter, it returns the parameter. So a duality is what you just saw, mapping iterator to observable. A duality is law of De Morgan, right? The negation of A and B equals not A or not B. In fact, the creator of Reactive Extensions is called Eric Meyer, right? He's one of the people that worked on C#, and he's the creator behind Reactive Extensions that originated in C#, and his company right now is called Applied Duality, which is where this all comes from, okay? And he's also helped actively in RxJava. And Eric Meyer said that if you think about it, what's the difference between an array and events? So if I take that list of numbers, which is an array of numbers, how is that actually different from a list of events? It's all just data. That's it. The only difference is that in our mind, event is something that's raised, something that is pushed to us, as opposed to something we pull out of a stream of data. Okay? You're following, right? Very simple. Brilliant. So Reactive Extensions is nothing but an extension over the observer pattern, and it has a bunch of operators to work with sequences of data and combine these sequences of data. That's why it's actually called reactive, because you react to events, and extensions because we're extending what's already there in the language. We're extending on top of collections, on list of items. And more importantly, it abstracts away low-level threading, callbacks, asynchronous programming, right? Those are the key things of Reactive Extensions. And when I talk about operators, I'm not joking. If you actually click on that, you can see that you don't have internet. But do you know what happens? You know this dinosaur? You know it, right? Yes. So while that happens, I will try and connect to... Oh, that was not right. Sponsors. So it starts to run and hopefully, go away. Okay, so that sucks. Where are you? Oh, we don't have sponsors. Never mind. Anyway, what I'll do, instead of showing you the operators, I'll play this for a while. No, there's actually, like, there's a screenshot later. There's a whole bunch of operators, and we're going to go and see through them. So there's flat map, there is zip, there's zip with, there is combine, there is last combine, there's a whole bunch of things. It's a whole library of operators that allow you to do a whole bunch of things. Now, Reactive Extensions has grown beyond C# and has grown beyond Java, and RX Java now is kind of like the reactive site is the umbrella for all of the different language implementations. You have RX Java, JavaScript is RxJS. So JavaScript developers, all the hipsters have realized that there are like patterns and stuff in the world. C#, RxNet, C#, you know, there's Scala, Clojure, there's even Kotlin, and I'll tell you why that's good. And there's also frameworks that are providing adapters. So frameworks are now understanding that there is this API which is called reactive programming, and we're going to provide you with a surface, an API, a wrapper for you to work in that way. RX Android, if you're doing Android development, you should be using it because it really does cut down on the way you have to manage asynchronicity in Android applications. There's RX UI, which also works for Cocoa. So basically, it's there for everything you can think of. React.js, you've heard of React.js? It's the next best thing, which means basically everything else we've done in our life we have to dump because they told us React is the next best thing. Sarcasm there as well. That is nothing to do with reactive. They just thought, what name can we pick that will not confuse people? I know, React.js. Let's do that. But it's React.js is not reactive. There are extensions to try and make React.js reactive, but it's not reactive. Now it's all just about demos. Okay, so any questions? No? Brilliant. We'll proceed with demos. And I do have a couple of slides. Okay, so let's start with a very, very simple thing. This is the observable pattern. Okay? This is the minimum you can get. And when... So, my IDE is hung. If only I could use a decent IDE. Oh, there you go. Oh, there. Oh, I thought I was using a different IDE. No, it didn't hang. I was just pretending, yes. So here is basically like, this is not what you're going to do. So I'm going to show you what you should not do first. An observable class that implements this thing called an observable interface of type string, and to shortcut things so that I don't have to write all of this code manually, there is a parameter of type onSubscribe from iterable, which basically means, in all ways, create an observable that subscribes to an iterable. Okay? So what this basically means is that when I run this, I can now create an observable with a list, an iterable list of items, and then I'll create an observer, and then I'll have that observable, the observer, subscribe to that observer. So if we run this, what you basically get is it's going to subscribe to that observable, and it's going to call onNext for every item there is. So it's going to call onNext, and it's going to print A, onNext B, C, and then when it finishes, it says sequence completed, and then if there's an error, it says on error thrown. Okay, and we'll see that in a little bit more detail in error management a little bit later on. But that's basically as simple as it gets. Now, of course, this isn't the way that you normally do it, so we can do a little bit better, and we can do an observable refactored, right? So here what I'm doing is, instead of having to create a class, which is an observable implementing that, I can just use this factory method, which is create an observable from an anonymous object. This is how you can create an anonymous object in Kotlin. You just write object and then the interface it implements. And that interface, in this case, just has a single call, which is called call, which is going to be called for every item of that observable. Okay? Now, you don't normally create observables. We'll get to that later, but you normally don't create observables like this. And here I have the observer, same code, I'm just doing the same thing, and if I run this, it does exactly the same thing. Okay? So far, so good. Now let's go and see something a little bit cleaner. This is basically the same thing, but instead of passing an anonymous object, what I can do is pass a lambda. So if you're using Kotlin, or you're using Scala, or you're using RxJS, or you're using Java 8, you can now make use of lambda expressions and just pass in lambdas. So all I'm doing is exactly the same thing, but cutting down on boilerplate code. And here I have a list of elements, and then I'm looping through those elements, and I'm calling on next. And once they finish, I'm calling on completed. Right? And then again, the observable is exactly the same. The only difference here is that I've not explicitly declared it to a variable. I've just said observable, subscribe with this pattern. Okay? And if we run this, I promise you that it gives us the exact same result as the first one did. Okay? You can, oh no, I lied. The first one said element A. This one just said A. I'm sorry. From now on, you won't believe anything I say. So now if I go an observable from, an observable, oh, it's a file, sorry. So there is some shortcuts. Just like there's observable create, a lot of these things we're going to do over and over again. So RxJava provides a series of shortcut methods for it. And in particular, there's one called from. And what from does is create an observable from a list of iterables. So all of that code that I just showed you, forget about. You don't need it. This is what you do when you want to create an observable from a list of iterables. So I say create an observable from list of ABC, and then subscribe. Right? And now in the subscription, I can say what to do on next, what to do on error message, what to do on sequence completed. So what is the difference here from the previous one? This one, all we were doing is just printing out. So this was basically implementing on next. Why? Because if you look at the signature to this, if we write observable subscribe, there is subscribe, you see that there's a whole bunch of methods. There's a whole bunch of overloads, right? So I can actually get parameter info here, and I can see that there's one that just takes an on next. Then there's one that takes an on next, on error, on completed. So I was just doing the shortcut, you know, like all good programmers, not doing error handling, and just saying, if all goes well, this is what's going to happen. If something goes wrong, well, tough. Here I'm being a better programmer, and I'm saying, okay, I'm going to implement the on next, I'm going to implement the on error, and I'm going to implement on sequence completed. Okay? But the point is exactly the same. Now, let's go ahead and run this and see what happens. So you see it says element A, element B, element C, sequence completed, something, element A, element B, element C. Right? So what I've done is it's looped through this, it's printed it out, and then it's printed something, and then it's come here and printed ABC again. So 2 subscriptions. Now one thing is very important here to notice, and we'll see the difference here, that every time I subscribe, it's going to go and loop through all of the items again, right? So it's kind of like every subscription gets its own instance of the observable, right? There's no real state management in the observable, and you should try and avoid state management in observables, okay? So let's move on and let's do something interesting with this, because right now it's just really, really silly, right? So here what I'm doing is I'm creating a list of observables from 1 to 100, and then now this is where I'm starting to combine it. This is where the true power of Rx comes in, because all of these operators are part of the Rx library, right? So this is an observable of filters. Now notice that this is different from the filter that you give that you get in Java or functional languages like Kotlin, that you just say filter a list of elements. This is acting on observables. So it's extending the language to now provide support for observables. And what I'm doing here is I'm saying loop through this, filter those elements that are divisible by 2, then map them to another value, which also gives me an observable. On that observable, filter them again, multiply them, see which ones are divisible by 7, and then for each of those, print out the results, right? So we're combining all of these the inputs and outputs of each process, yeah? Now again, you're looking at this and you're like, well, what's the big deal? I mean, the application starts here and it ends here. Yes, but remember that this doesn't necessarily block, and we'll see when it blocks, when it won't block, because these operations are meant to be asynchronous, okay? So let's go ahead and see some error handling. So here now it starts to get interesting. So you see what happens when an error occurs. Okay, so I've created the full scale observable here, and I've said, you know, for 1 to 20, sleep for 100 milliseconds, and then spit out the next number. And then I say, if the number that you spit out is divisible by 5, go ahead and just throw an error. And then if in unsubscribed, break the loop. And then if not, if nothing happens, go to complete. Okay? So now I have an observable, and I map, and I say I've received the number. And let's just comment this out for now. And let's go with the first one. So if I run this, what's going to happen? Who can tell me? I'm going to print out some numbers. When is it going to stop? We don't know. It received 2 and then it stopped, right? Now notice that it says on error not implemented exception. So it's saying the error was thrown, but you've not implemented the error exception. Now the key thing to notice here is what happens is basically if an observable throws an error, it stops. Stops dead in its water. But it doesn't do it with a try catch. It gives you the option to handle that error with a function called onError. And now in this case, I've not handled that error, so the program just basically stopped. Now what I can do, which starts to get really nice, is I can say, you know what, if an error occurs, I want you to retry. Yeah? So here I say received. If an error occurs, I'm still not handling the error in the sense of on error thrown, but I am saying if an error occurs, retry. And that's an operator that's built in. And this starts to become really awesome, because now think, for example, you're trying to do a URL request and it times out, and you say, okay, you know what, retry for 5 times. Imagine implementing that code yourself, right? So you see, this has actually, if you debug this, you'll see that it has retried. It will throw an exception once, but it says, hey, you know what, it's told me to retry, so I'm going to continue the loop, right? And then we can now do, for example, error catching based on not only retries, but conditions. So this was the first example, which is saying, you know, only stop as long as the error is different to number exception. So if it's this specific exception, don't worry about it, just continue. So it gives you operators to be able to do different things with error handling as well. Okay? Now let's see like a real world demo, because this is where it kind of like you can start to do things. I have some socket server here. So what I'm doing here is I'm launching a bunch of sockets, and think about the way that you're going to use this is normally you would have like streams of data coming in, right? This is the whole point. The whole stream comes in that there is no end, right? I can just continuously push data. I can continuously push events. And then at some point, when I want to unsubscribe, I can unsubscribe. If I don't, that data continues to come, and I continue to handle it. So here I have like a socket server, and what this socket servers are doing are basically simulating that it's reading data from random files, from access logs, etc. Right? So now I can like talk to these sockets. So here you can see that what I'm doing is I'm creating an observable that talks to a socket. And here what I'm doing is reading the line, I'm seeing if the line is not null, and then I'm spitting out that line. So this is constantly, it's subscribing to that and spitting out the line. And then I'm continuing to read the line. Once it's completed, I complete and I close the socket. Now this isn't normally the way you would do it, because here there's resources that you need to close off. And there's an override method in Rx that allows you to say, do this operation with these resources and dispose them at the end, right, as 3 parameters. So then what I do is on this socket observable, I say filter everything that has the URL twiki bin rdiff main, which is basically some URL that's coming in through the log files, subscribe to it and print it out. So if I run this now, okay, if I also use the keyboard shortcut, that works, it will start to like process this data, and once something comes out, it will spit it out, right? So you see, that's not the entire log file. If you open up the log file, you see like it's 10,000 lines, Okay. So this is interesting. Now it's kind of like, okay, you know what? I can be reading from sockets, and then if data comes in from one socket that matches some pattern, I can collect that and I can merge it with some other result, and I can push that back to something else, etc. Okay. This is where you start to be able to combine some of the power of RX. So now let's go and see how all this acts in terms of logging. So now this one you've got to answer me. Really, please, don't remain silent. Here what I'm doing is there's another function which, instead of from taking a list of items, what it's going to do is it's called interval, and what it will do is start to emit numbers, right, integers, in a time unit that we specify. In this case, I'm saying every second emit a number. If I run this, what's going to happen? Who can tell me? Yes? Okay, it's going to start printing numbers every second. Who says otherwise? You say otherwise. Right. We'll see. Yeah. So it ran. It didn't do anything. Why? Pardon? Exactly. So this, what you've seen so far, and this is where you start to get the picture of the asynchronicity, is what you've seen so far. When I do, for example, a from, and I do a subscribe, it's loop through that because it's a finite list, and it's going to loop through that on the main thread, and it's going to print out, and it's going to subscribe on the main thread, right? And this is a console application, right? So all of that was working because I was on the main thread, I was subscribing to a list of items, I was printing them out, and then I was terminating. Normally, you don't have this kind of, start, finish in your application. You normally have an event loop. So you could write that code, and it's perfectly fine. The difference with interval is that it's not going to use the main thread, right? So if I do that, it's just basically 1 second hasn't gone past, and it's done. The application's finished. Now, if I do something like while true, which is also how you create, probably some code like this is in Skype somewhere, what's going to happen is, let's see, it's going to print out data, and it's never going to stop, right? And that's because interval is taking place on another thread. Okay? And we're going to see these threading things in a second. So here it's the exact same thing, but instead of doing an empty while true, I can actually say convert this observable to blocking, which is an anti-pattern. You normally don't convert an observable to a blocking. But you can do it like that. And you can say convert this to a blocking and then print out data. Right? This is sometimes useful when, for instance, you really need some result to come back before, for whatever reason you need to block, you can do to blocking. But if you start to use observable pattern and you're calling to blocking everywhere, that's a sign that you're doing it wrong. Okay? It's rare cases where you would use blocking. Okay? So let's see why this is occurring, actually. If we go to scheduling, I have a whole bunch of examples here, right? So here's a main thread, and what this is doing is creating an observable from 0 to 10, and then I've got to subscribe, and I'm going to print out the thread name. That's just a utility function in Kotlin that just gives me the current thread name, okay? So let's go ahead and activate this, and then we'll run this, and let's see what happens. So you see it says I've received 1 to 10 on main. Okay? So it's actually executing on the main thread. Now, let's go and do something different. Here what I'm doing is I'm saying computation thread pool. So what I'm... Hold on. That's not the one I want to show you. Okay. Yes, actually I will show you that. So let's do the computation thread pool. And let's see what happens. So now you can see that it's saying main, and then receiving 0 on thread pool. So what exactly has happened? Okay, where is the computation thread pool? Over here. The only difference is that I went from to using interval. Interval is not running on the main thread. It's running on this internal thread pool that Rx has, which is computational thread pool, right? And that is why the receiving it on is receiving it on the computational thread pool, but this line got executed on the main thread. So this is where you can start to control these thread pools. This one's controlled inherently because this constructor interval by default uses that. But I believe, if I'm not mistaken, there is a third parameter which is called scheduler, which allows you to define the actual threading model. So Rx also allows you to abstract the threading away by just specifying how you want things threaded. And there's different options. So I can now come here and say scheduler's computation. And if I delete this, which is the default, you can see that I have IO, new thread, trampoline, and all of these have different meanings. But you can actually define on what thread you want something to be observed on and what thread you want something to be subscribed on. And it's very easy also to get you in deadlock positions, right? So, you know, we're taking the threading away. Now we're giving you a nuclear bomb, but you can still kind of shoot yourself in the foot if you want. Okay? Not nuclear bomb, something nicer. Hash brown. You can smash your head with the face of a hash brown. Oh, never mind. Anyway, so, you know, it does allow you to do a whole bunch of things, okay? And of course, it doesn't stop there. Then you have these concepts of hot and cold observables, which you'll come across. What you've seen so far is basically cold observables, which means that every time I subscribe, it starts to emit data. And then every new subscriber gets that data from the beginning. Then there's this concept of hot observables, which is basically the data is continuously going. And as new people and new subscribers join, they're just going to start picking up the data from where it is, not from the start. Okay? So sometimes when you're, for example, getting data from a stream that you can't control, a lot of times you get hot observables. And then, of course, you run into, I have a hot observable here that's getting data, and then I've got another observable here. I want to combine those because you can actually do combinations as well. So, for instance, here what I'm doing is I have two observables, and I'm doing a zip with. And I'm saying, get this data from these two observables, zip the results, and produce something else. This is where, you know, other powerful aspects that it has. The problem is that here you can run into situations where, for instance, this observable is coming into you much faster than this observable. So what happens? How much does it buffer? You can run into memory issues. So there are methods that allow you to do buffering. So for instance, if you look at buffering, there's a debounce, which says wait 3 seconds and then grab whatever there is and then pass it along. So like capturing things by every 3 seconds. There's a whole bunch of API calls to also allow you to do buffering, okay? So it's really, really quite powerful. So with that, is this the silver bullet? No, because there is no silver bullet, and I hope you know by now. But where it does help is with asynchronous code. It does help you in terms of combining results. It does help with ways where you're doing event programming, and a lot of things you can start to think of as events, right? I mean, in essence, what this is a pub sub. It's publish, subscribe. The same way that you have like with event buses, right? And message queues. It's kind of the same concept. And it does help you better in terms of error management. But one of the beauties of it is that beautiful flow of just, you know, pipelining results. Data, I do some code, some data comes in, I do something with it, and I move on. Okay? And most importantly, it's adding a layer of abstractions. So, you know how they say that, like, you know, functional programming raises, or I will say that in an hour. Functional programming raises the layer of abstractions and the primitives in the sense that now you work, well, the primitives are now functions. Here the primitives starts to become streams, streams of continuous data. And you start to think of data as infinite, as streams, and you can work with these streams, right? It's raising that API level. There are some issues. It has a learning curve. You have to think a lot in functions. You have to think a lot in streams. And as I said, you can still cause havoc. You can still cause deadlocks. If you start to mess around a lot with schedulers, that can leave you with issues. And it doesn't automatically give you parallelism, right? because you can screw up and you can actually do state management inside an observable, so that can lead you to problems in itself. If you want to learn more, go to the ReactiveX website. There you get a link to a lot of different tutorials. Some of the good ones are from Anders, where is he? Andre. The Introduction to Reactive Programming, you've been missing, that's quite nice. He's also done a website which is called RX Marbles, which unfortunately I can't show you because my internet doesn't work. But this is an interactive diagram. So you get all of it has all of the operators for RX, and then you can actually click on these and move them left and right, and then you can see how it results. So if I take the top stream and I do a merge with another stream, what do the results do? Okay, so they're interactive. Don't just look at them like that. Start to click on them, and you can see that they're interactive. So those are very good to get an image of how, when you're combining and using operators, what exactly it does with the stream of data. Okay, with that, we're done. Thank you.